Hello and welcome to this video. We're going to be talking about objects, mostly the basics. Let's get started. Okay. So why do you want to learn about objects when we talked about programming? Well, you have learned about how to make functions, and functions have interactions together, right? But when we think about creating large softwares where you have hundreds or even thousands of functions, the management of the complexity becomes very difficult when we work in that scale. So it's all about making efforts into managing the complexity, and object-oriented programming is one of the approach that has been proposed to do that. Okay? And Python is object-oriented programming language, so we can implement this using Python. But you do have to note that not all programming languages support object-oriented programming, such as C, Fortran, COBOL, and so forth. Okay? There are other methods as well, things like aspect-oriented programming and so forth, or type-oriented programming. But it's really about how you conceptualize managing the complexity. Okay, in practice, object-oriented programming has been used widely, so it is essential that you understand how to think in an object-oriented programming manner. Okay, so let's look at the procedural programming, which we are very familiar with. So we wrote programs, the functions, to do small things that they're good at, right? And to solve some complex problems, we use different functions in combinations to solve the problem. But when the problem becomes very complex, we have a lot of dependencies between those functions, which makes it difficult to manage how these functions, how the data flows between the functions, and how to troubleshoot, how to manage them, etc. Okay, so as the program, as the software gets larger, we have what we call a spaghetti code. Okay, so too many things are jumping everywhere. So even though we came from a non-functional procedural program where you have every single code written without functions, that becomes very quickly unmanageable. So we use functions, but even using functions, it can be very difficult to manage. Okay, so instead, object-oriented programming is adding, simply put, hierarchies. The way you group things together makes it simpler to manage your software or the program, and that's thinking from objects perspective. Okay, so what does that mean? What we're going to do is group different functions and values together that they should be associated with from one another. So here you see on the left-hand side, there are two units, one highlighted in yellow, one highlighted in red. But they are separated because we think that those are two different types of objects. Okay, and within an object, if it's a function, we call them methods or behaviors, usually methods. And if it's a value, we call them usually attribute or property. Okay. So let's give you some examples about that. So a singer is an instance of an object. We can think like it's an object, right? It's a thing. A singer is a person who sings, right? So singing is a method provided by the singer object. Okay? And there can also be multiple instances of singers, like vocalist, soloist, songster, songstress, and so forth, right? So let's have a look at fruits. Fruits can be regarded as object, and there are many different types of fruits, right? So you can create an instance of fruit, such as banana, apple, kiwi, strawberry, right? But they're all still part of what we call a class fruit, right? We can also have other objects like animals, right? Rabbit is an instance of an animal. Bear is an instance of an animal, and so forth, right? So by thinking in groups of what we think is an object, makes it easier to manage complex systems that way. So here's another one that's quite abstract. So for us, physical things are objects, but in computers, anything really can be an object, right? So anything that can have a such hierarchical relationship, we can create them as an object. So rectangle, for instance, can be an object. So we define a class rectangle that's defining an object class. And then we can create different instances. So here, the 4 different rectangles below are instances of a rectangle object, right? But they can have different properties, right? So this one, you can have a different fill color, different border line color, the width, and so forth. Okay? So you probably picked it up by now that object-oriented programming is all about type abstraction. Okay, so if you think about color, we often use multiples of them. For example, if we are setting a pixel value for a monitor, we need to define 3 values, right? Red, green, blue. And we can probably pass this around back and forth to do stuff, right? So as the video plays, we need to update the pixel value as the time goes on. If you also think about games, like a chess, for instance, you need to have the row and column information using the board and the player. We can create a new board and make a move and so forth, right? Of course, we can achieve implementing these using like tuples, lists, dictionaries to group these, but it can get quite confusing later on. For instance, the orders can be confusing if it has a lot of attributes, a lot of values, then that can also be confusing and so forth, right? So the solution here is to apply type abstraction, which means writing your own class defining its own characteristics. So anything that we can apply hierarchy to can be created as an object. In fact, in Python, anything can be created as an object, but it only makes sense to create an object if we can define such characteristics. Okay, so color is one good example because there are various instances of colors. For in this case, we have red, green, and blue, right? And any mixture of red, green, and blue can create the colors that we see on the screen. Okay, so let's have a look at the code. You can copy and paste. So do note that we created a color class. However, we haven't really created any methods or attributes inside. Okay, but we created an object, which is called color. And then we have a display function, which is not inside the class. So this is a separate function, okay, which prints the color of the given object called color. Okay, so color equals color. Remember, we have to provide a bracket. By doing so, we are calling the constructor to make a color instance. Okay, but currently it doesn't make much sense, but we'll see. And then we are creating below here the attributes of color. So we are defining the red, green, and blue with these values. And then finally, we call the function display with the color instance to display its values. So this is quite straightforward. We run this. Just tells me that red, green, and blue values are set to these. Okay, so this kind of makes sense, but so far we only achieved one thing, right? Being able to create red, green, blue attributes of an object outside. So in fact, that didn't really do much from what we know so far. Okay. So we're going to improve this by creating an initializer. Okay. So in all the class you define, we'll have an initializer, which means when you create the instance of the object, then this initializer gets called in and define some of its default values to start with, right? So let's do that. Which is down here. Okay, so here, instead of having the 3 lines outside the function or the class dot red dot green dot blue, what we have done is have migrated that inside our initialization function. Sorry, the method. Okay, so this time, so this time what's happening is rather than defining the attribute values outside the class, we are going to pass in those values when we create the object. So here you see that the lines of code has reduced to 2 because we just have to pass in the value of RGB when we create the object color. Now our instance of the color object will have these values as part of its attribute. Okay, and do note that there is this self, which means the object refers to itself. So it's a special letter that we use to refer to its own attributes and methods. Okay, so self.red equals red. So this red is the passed in value from outside the class, whereas the self.red is the attribute value associated with the instance that you're creating. Okay, so red is 255 when this part of the code gets executed. And then when the self.red is executed, then we have access to color.red, which has now value 255. Okay. So if we run this code, we have exactly the same output, but the way we are managing the code, the object has changed. So we let our class initialize the values by passing in the value, the input parameters. Okay, so this means we can create multiple color instances. Color2 equals color 1, 2, 3. So it's not a very bright color, but we can also display color2. Oops, color2. And if we run this code, we get the color attributes of the first one and also the color attributes of the second one. Okay. Now we can make this even better because we had a display function separated from an object, but technically that display function can only work with color class. So it makes sense that it belongs as part of the color class rather than being a separate function. So next part of the code places the display function and converts it into a color method. Okay, there's not much change from before, but instead of calling color dot, now we're calling self dot, red, green, and blue. Okay, so since this display function has moved inside the color object, I no longer need to take an input because this display method belongs to the object already. So this color object knows how to display its own color. Okay, so all the reference we need is just the self. Okay, so if we define a self inside an object, we don't have to pass it in, because when we call color dot, then that object is passed in as the self. Okay, so that's the self object itself. Okay, so if we just execute this, we see exactly the same output as before. However, this time we have moved our display function inside our color object to become a color method. Okay, and here is a quick upgrade from the previous one. So we have defined a display method ourselves, but technically that is just printing output about what the color attribute values are, the red, green, and blue. So technically, we can just print our object, and it should display that. And there are built-in name for that, which is underscore underscore string underscore underscore. Okay. So now all we have to do is replace the name display with our built-in string name. Then we don't have to call the method, but we can use the print function instead. So we can print color and get the same output. Okay, so let's do that. So we have the same output. However, if you don't have this print method, so I'm just gonna comment it out and trying to print color, then the Python does not know how to print this object. So all it's going to tell you is a reference to the object located at a certain memory location. Okay, so that's why if you define your own object and you want to be able to print it, you should create the string method for it to be able to print. Okay. Okay. And here is a completed color class, which has exactly the same code you have seen before, plus this lightness method. Okay, you can pause the video here and quickly check out what this lightness method do. But if you're done, we want to check out exactly what it does, right? So what does this lightness method do? Well, all you have to do is just read the docstring, calculates the lights of this color defined as the average of the strongest and weakest RGB values, scaled 0 to 1, right? So it's probably not the best way to calculate how light it is, but it does the job. So we can run this and test the code. So we're going to create black equals color 0, 0, 0. Okay, print black. Black dot lightness. Lightness doesn't take in any extra parameters, so just empty brackets. We also have white. Oh, no, not white. White equals color 255, 255, 255. Okay. Print because I'm not inside the terminal. White dot lightness. Okay. This means I need to print this too. Print black dot lightness. We also have yellow. Let me just copy and paste this. Copy and paste. Yellow is 255, 255, 0. Okay, we can also assign a separate reference, y2 equals yellow, and then we can print y2 dot lightness. Okay, so now we're going to run this and look at the output each. So first print one is black. Obviously black has 0 value for RGB. Okay, so that's expected. And then it prints its lightness, which is also 0. So the max value, min value is also, they're both 0. So average of that is 0. Next one is white. Well, obviously the lightness of white is going to be 1. It's the brightest color that we can create in these values. And the yellow's lightness, we actually didn't print out the yellow lightness, but it's Y2 lightness. But you can assign Y2 equals yellow. Okay, what does that do? That's actually not copying the values from yellow to Y2. We're just creating another variable, Y2, which points to the same object, yellow. Okay, so in the memory space, there is only one object that's the color object that's created with the value 255, 255, and 0. Okay, and inside our dictionary, the variable named yellow is pointing at it, and variable named Y2 is now also pointing at it. Okay, so we can do things like Y2 dot green equals now 0, and then print yellow. Okay, so you'll see that the lightness, after the lightness, this is the last item that's printed. So you see that I changed the value of green to be 0 for Y2, but when I print yellow, its green value is also 0. So you can clearly see that there is only a single object. It's just that we have two references, Y2 and yellow, that are pointing at the same object. So this is the aliasing problem, kind of like aliasing problem you've seen in with the lists and the nested lists. Okay, so do worry about these kind of things. Okay, so we have seen the initialization and the string methods, which are special methods. All the special methods start with the underscores and ends with the underscores, the two of them. Okay, and there are more special methods like this, which you can find from the link provided here. But some of the popular examples include add, subtract, multiply, and equivalent. Okay, so when we talk about whether the two objects are the same or not, the color one is quite straightforward. We just have to compare the RGB values, whether they are same. But if we talk about some other more complicated objects, then definitely the way we define these special methods can vary. Okay, so now we're going to implement the plus operator, okay, which looks like this. So let's do that. Just going to get rid of this. Here's the add method. Copy and paste. Okay, so I got the add method, and basically what it does is you have to provide other color instance here, so it accesses its own RGB values, and then try to add them together. And if the sum is greater than 255, we'll just keep it as 255. Okay, so that's all it's doing and returning the color. Okay, so to test that, let's create red equals color 255, and then green equals color, and then another equals red plus green. So when we call red plus green, what it's actually doing is calling the add method of red. So it goes red dot underscore underscore add underscore underscore open bracket, and then parse in green, and then calculates that. Okay, and then we'll print another, and then execute this. Oh, I have an indent error. Oh, Okay, so now we print that. We get 255, 255, 0. So in this particular instance, we are creating a new color object. So you can see that we are creating a new color object by passing in the values of the RGBs added together and then returning that. So as a result, another is actually a new color instance that contains the values 255, 255, 0. Okay. So next, we're going to look at function objects. Let me explain better about what I mean by function objects. But for this one, we're going to use this particular class called person. Okay, so our person is here. You can copy and paste this into your IDE. Okay. So for example, we want to use functions on objects. Okay. For example, we want to sort a list of person objects. Okay. And when you think about sorting numbers or strings, the sort function will use the less than operator to sort things, right? So for instance, we can try to sort the people by their names, right? P1.name is less than P2.name, okay? But what if we want to optionally sort by name, age, student ID, area code, and so forth, right? So some people might be interested in sorting people by different attributes, right? So we can do this by passing a function to the list.sort to specify how it should be sorting the objects that we want to sort. Okay, this is called the key parameter. So it's very similar to keyword parameter we have seen in functions, right? So let's have a look how it's done. To do this, we can create additional functions like here, the name or the age that returns the attribute of interest that we would like to sort it by. So the first one is just returning the person's name, whereas the second one is returning the age, right? So after that, what we can do is trying to sort it by the key, okay? And in this case, the key is going to be name, and this name is not the attribute name of the person object, but the function name. Okay, second one is the function name age as well. Okay, let's see how that works. Okay, if you're doing it in the shell, you don't have to print. If you're doing it from the file, you will have to print people to see how that has been sorted. Okay, so in addition to the person class, we write two functions, simply just returning the name and the age attributes by each. Okay, people, we have a list of people, which is just a person called Fred Block, who is 123 years old. Malcolm X, also 120, very old people. First time, we're going to sort it by name. So this time, if you are sorting by name, we will see the capital F is going to be smaller than capital M. So Fred should be in front of Malcolm. And second time is going to be sort by age. So 120 is smaller than by 123. So Malcolm is going to be in front of Fred. Okay, so we execute this. Okay, so as expected, Fred is in front inside the list, followed by Malcolm when it was sorted by name and then printed. But second time when we sort by age, Malcolm comes in front and then Fred comes after because Fred is older than Malcolm. Okay, so if your object has more attributes that you want to sort it by, you can create additional functions that can be parsed in as the key for the sort method. And what this really means is that functions are just objects in Python. So for example, we can create def print message. So let's create that. I'm going to comment these out. Okay, just quickly do it here. Python 3, def print message, print message. Very simple function. Okay, then we can create another variable called thing. Let's just call it thing equals print message without the brackets. Okay. Now what this means is print message is pointing at the function object. So thing is now also pointing at the function object that I created above. So I can do thing and hello. And it's gonna say message is hello. Right? So specifically a function is a callable object, right? That means we can call the function because it's an object and use it as shown here. Okay? And this allows you to do a lot more advanced stuff in Python, but in this video, we won't get that far. Okay, so what have we done so far? Well, we've abstracted a new type of object using the example color. Our color class specified the initialization method, which in turn defines the attributes, the red, green, and blue. And also the capabilities for the object type, such as being able to print it, as well as adding customized methods like lightness. Okay. So in this context, we say it encapsulates both the representation and behavior of colors. Okay. So now we can create and manipulate colors more easily. This also means you can create objects of other stuff, right? So just look around and see what kind of objects you can create and have a go. Well, that concludes this video. Hopefully you found learning about objects is not too difficult. The whole concepts of object-oriented programming, which we'll look in the next video, is a little bit more complicated, and it can get very complicated. But hopefully the basics of objects gives you a good idea why we want to look at things in object-oriented way. All right, so that's it from me. I will see you in the next video. Bye.